Hello everyone, I'm going to discuss the continuation of our topic about building envelope systems and assemblies, the moisture transfer, durability, energy, and material resources, which is the design application in terms of sealed roof, walls, and floors. So let us recapitulate first what is building envelope. Building envelope is everything that separates the internal building from external environment, including the roof, walls, and floors. Good insulation in the walls, floors, and roof, and sufficiently sealed gaps increase the effectiveness of the envelope. Roof. The roof shields a structure from harsh elements from sunshine to rain, so it is important to seal it off and reinforce it. So roof system serves as a barrier against air, rain, snow, and other harsh elements. So this is a metal roof edge flashing with rubber closure strips to seal ends, valleys, and joint terminations for airtightness or the control of air leakage and the elimination of unwanted routes through the external fabric of the building. So this is the airtightness at the roof ridge. First picture is a wall to roof flashing airtight closure, and the second picture is airtightness at call and roof eaves. So next is the wall. Wall separates the indoor and the outdoor environment of a building. Its functions includes environmental control, but the main role of walls is to act as a moisture barrier. It is detailed in the illustrations below. So the first picture is the application of moisture barrier on exterior wall. The second picture is concrete wall in paint finish with moisture barrier properties. Next is floor. So when it comes to moisture seepage, it is also important for floors to be treated and reinforced. Wall foot. So this first picture is wall footing details showing application of joint filler between wall and edge of concrete slab and the application of damp proofing below slab to prevent moisture seepage and gravel bed to allow drainage of water. The second picture is a roof deck waterproofing membrane. So these pictures are the systems for treatment of joints in the building envelope to avoid air leakage and moisture penetration. So these are the concrete floor maintenance systems, structural glazing, flushing systems, paver and planter systems, waterproofing systems, and seismic joint systems. Energy envelope flows. So the envelope is a composition of layers with varying thermal and permeability properties. The envelope may be composed of membranes, sheets, blocks, and pre-assembled components. The choice of the envelope is governed by climate, culture, and available materials. The range of choices and envelope design can be illustrated by two opposite design, the open frame and the closed shell. In harsh climates, the designer frequently conceives the building envelope as a closed shell and proceeds to selectively punch holes in it to make limited and special contact with the outdoors. So, the external influence by harsh and visual clutters. So, when external conditions are very close to the desired internal ones, the envelope often begins as an open structural frame with pieces of the building skin selectively added to modify only a few outdoor forces. The flow of heat through a building envelope varies both by season. Heat always flows from hot to cold and generally flows from a building in winter and to a building in summer, and by the path of the heat through the matters of building skin or by outdoor air entering. So these complexities must be considered by a designer who tends to deliver comfort and energy efficiency to the residents of the said building. wall. Understanding and optimizing the heat transfer through the walls is important in high-performance building design. Using thermal mass and insulation to your advantage with passive design strategies can help reduce the amount of energy that active systems need to use. So the thermal mass is the ability of a material to absorb, store, and release heat. The example of thermal mass that can be uses in a wall is concrete, brick, and tiles. So these materials is considered as high thermal mass. Insulation. Thermal insulation is a material that blocks or slows the flow of heat through the building envelope. Insulation is a vital tool. It's a vital to most green building design because it allows space to retain what heat they have while avoid gaining excess heat from outside. In other words, insulation is a material that resists or blocks the flow of heat energy. Total R values and thermal bridging. In order to know the building's true thermal performance, you must calculate overall R values for assemblies like walls, roofs, floors, and glazing. The total R value or overall R value of an insulated assembly may be higher or lower than the R value of the insulation, depending on the assembly's construction. The thermal bridging is when the overall R value is lower than the insulation's R value. So that would be all. Thank you.